Okay. So just a quick, my background. I've been a developer and software engineer for a good 15, 16 years now. My last 2 years, I've been dealing with running a chat, which included research back into different ways of how do you communicate with the server. So, so just go into the different types of communications. There are two main categories. There's going to be the near time communication, which is going to be stuff that is making network requests and either waiting for information to come back for you or to you, or it could be polling. So the two main examples of that's going to be your slow polling and your long polling, which I'll get back into later. And then there's real-time communication. This is where it's looking for information that is coming back to you really quickly, almost instantaneously. So we're going to be looking at server-side events for that, as well as WebSockets. Common UX items that this is across the board, doesn't matter which one of those items that you're going to have, is going to be your accessibility. So you're going to have to think about stuff like when a new message comes in, what happens? How do you notify the new user? Or how do you notify the user? Other things that you can have to think about with this is there an audio response to it? Where do you take the user when a message comes in? Do you take them away from where they're currently at, if they're at somewhere else on the page, and bring them to that location or something else? The next item to look into is going to be kind of your, I call it the multi-3. It's multi-tabs, multi-device, and multi-browser. So you should be making the decision of, do you need to keep data synchronized across all of those items? So if I'm on a cell phone, what happens when I hit send? Does that also show up on the browser? Next item is order of messages. A lot of the times, especially when you get into like WebSockets and SSE, order isn't always guaranteed. So you might have to worry about that as you go through and go through and actually do development. Next item again, I'm going to say accessibility because, again, as a web developer, that's a very big thing in today's market. And it's been a big thing for a few years now, so it's always keep that in mind. Now going into common server concerns. How are you going to handle timeouts? So if you're doing long polling, for example, you're going to have a timeout in there, what happens when that timeout occurs? Same thing with SSE. You can, in theory, have not really timeouts, but when connections drop, what happens? Next item is race conditions. So as messages come into your server, what happens if you get too many at once? And when you get into the long polling and short polling, you don't have that issue, but when you get into like WebSockets and server-side events, you can. Connection management. Again, this is another one where it comes down to mostly WebSockets and server-side events. But there is also a question of how do you do things like, what's the right word for it? Sorry. Throttling and making sure that you're not giving DDO or DOSing your own sites. Cost is another big one. Each one of them has its own cost, especially if you're up on the cloud. And then security. Each one of them has its own little tweaks when it comes to security. So slow polling, to start off with. Slow polling is when you will have a whole bunch of network calls that happen on a consistent interval. A lot of the times this is just going and saying, hey, go grab me data. Do you have data? If you don't have data, return nothing. And then when I make a call to get data and you have it, return it. So I'm actually a big fan of a site called Animated Knots. So this is my take on animated network sequences. So as we can see, for slow polling, is you got a network request from the client to the server. Client doesn't have any information because it's still working on grabbing it. A few seconds later, the client makes the call, same thing. It doesn't have the data yet. Then you have another one a few seconds later, asking again, the client's asking, do you have the data? It says, yes, here's your data. And then, again, it's because it's on a continuous interval, now the client starts off the cycle all over again. So from a cost perspective, this is actually on the cloud, this is a low cost item, low to mid, primarily because all you're doing is you're spinning up a Lambda that's going to be very, very short-lived. So your cost is going to be minimal. From a UI complexity, it is a high complex item, primarily because like with React, you have to make sure what happens when the component that that's actually talking to the server gets unmounted, what happens, as well as how to handle the messages coming in. And then from a server item, complexity is about a medium. This is mostly going to be your standard request and response, but you also have a background process that could be doing processing, and then you don't get the information back until that processing is done and the client makes a call. Server security complexity is low. This is using a standard HTTPS request. There's nothing special that you have to really worry about. You can do your authentications on every network request without any issues. Primarily, and the reason for that is because this is not a long-lived connection, and it's short-lived. So just from a quick code, and yes, I will admit this is generated by AI. It actually did really well, which surprised me. So this is React-based. Effectively, the biggest things in this to notice is going to be the fetch APIs is just making a call to the data every in this case, 5 seconds. When you're fine-tuning things, you might find that 5 seconds is too slow. You might find that it's too fast. You really should be looking at, from a server perspective, what's the right number for your server and your user count, so that way you don't actually take and basically DDoS your own servers. Any questions on the code before I move on? Nope. Okay. Next one I'm going to go into is long polling. Long polling is more of what we use today, or what's used today for just a standard HTTPS request. The only difference is with long polling is you are taking and continuously making the call after the call ends. So you start a call, wait for it to finish, call finishes, make another call, wait for it to finish, and so forth. So from an animated network diagram perspective, it's give me what you have, it's working on it. It's a long-term call at this point. Network has, or the server hasn't responded yet. Client's still waiting, server still hasn't responded. Same thing, client's still waiting. And then the server returns information. Once this is done, this process will start all over again. So when it comes to costs,
obviously it varies with a number of factors, but is there a general rule for how long you can let the long polling go for?
That would be based off of, again, it's looking at your servers and seeing what that optimal timeout period is. So with all with all network calls, you got a timeout that you can utilize. So it's going to be based off of that. And that's where kind of that server complexity comes into play, is figuring out how many servers you can have up and running, how much network traffic that you can handle while keeping that open request. Cost-wise, this is a moderate because of the fact that you are having that open request, which means that you have to have those lambdas living for as long as it takes, or as long as they say they can live for. And once you get data back, you can tear down the lambda and open up a new one for the next request. So from a UI complexity, this one's actually is more of on the moderate side. And it's going to be related to again, how do I cancel a network request in mid-flight? How do I take and start that next network request after I'm done? How do I make sure what happens when I take and unmount the component on the client side? And that's with a React mindset, by the way. Server complexity, this is going to be a low to moderate, because again, this is just a standard network request where I send a request, I expect a response back. It's it's a long-term connection, yes, but it's one that will end. It's not one that stays open. Complexity for the server, it's going to be the same thing, utilizing HTTPS as the base. And then every time they make the net request, you can check authentication. So, as you notice from the code, there's a little bit more lines of code here. This one is actually using abort controllers in order to determine when to close the connection, if there's an error, or if I remember right, timeout. It also is checking to make sure that when you go through the long polling, sorry, take that back. It's making sure that if there is a timeout in this one, or a failure for some reason from the server, that it's not starting back at the polling in this one. So, any questions on the code? If not, go on to the next one. The next one is actually one of my favorites, server-side events. Server-side events is where the client will open up a unidirectional long-term connection to the server. This is going to be used for stuff like, you can use it for stock tickers, you can use it for chats if you have another API that goes along for sending messages. This is where the network will actually notify the client of any data changes. This is actually also one of the earliest things that I know I've learned about that actually utilize streams behind the scenes from the browser. The browser will handle a lot of the stuff for you. So I'll get into that once I get to the cost table. And there's a lot of nifty stuff that server-side events can do. So server-side event is, initially it starts up with just doing the connection. So you get client makes the connection, sends a message, server can respond anytime it wants. So if you notice that the server sent another message without the client needing to make any request. Server sends another message without a client making a request. I hit the wrong button. And then in this case is server sent a message, client said, hey, I'm done. I'm closing the connection. So after this point, the network or the server won't send any new messages to the client because the client closed. So cost complexity graph. The cost for this is going to be on your moderate to high side. This is primarily because you're going to have a lot of long-term connections with the servers, which means that your lambdas are going, if you're using like AWS, your lambdas are going to be spun up until the connection closes. So the cost there is on the high side. Complexity on the web, or for the UI. The browsers handle a lot of this for you. A lot of it's just a connect using the event source API. It handles reconnections for you. It handles it's a last event ID for you, which is a header. And so, I mean, it's a lot of that's already handled for you, which is nice. Server complexity is high though. So if you don't get a library that handles all those items, like the last event ID, retry connections, you have to actually handle all that on the server to the spec. So, go ahead.
So on the beginner of JS, how best practice for doing, like, for example, the short form, the long form, writing the code in JS and saying, sitting with that company that started the data before
So the question is effectively how to pay, how to not pay while you practice. So with all of this is you don't have to actually use like AWS to spin up a server or a Lambda. You can actually do this using, like Next.js, or take and insert any server that you have.
it's unrelated to JS, but when I was trying to do Python Selenium, I tried to use Google for practice. Me, a Kafka, but it was successful, I would have
Yeah. No, it's a valid thing because that goes into cost. It's like cost of how do you practice, how do you research that this is the right thing for you. The cheapest way I found is just spin up a Node.js server. So, no. No, but I say we can talk after to help you out. Moving on, actually, the one note though I want to actually move back to the web UI piece. This is just a note based off of experience I've had so far. In React Native, not all libraries that make network calls actually support streams or the long-term connections. So when you take and actually look at libraries and how to actually do server-side events, take a close look at those libraries because they might not be doing exactly what you think they're doing. So, security complexity. This one's on the moderate side. Because it is a long-lived connection, you have to worry about how do I unauthenticate somebody midstream. So if someone's cert expires midstream, how do I say, you're done, you cannot get any more information, especially when you get into some of the high security stuff or high security data. Some ways of doing this is to have the server send a message saying, hey, disconnect. I'm not going to send you anything more. And another way of doing that too is the server can tell the client that retry 0 and then close the connection. Once you do the retry 0, the server will stop trying to, or the client will stop trying to reconnect on connection on when the connection's killed. Correct. Well, you would have to programmatically do it on the server. Yeah. Another way of doing it is from the server can send a message to the client saying disconnect, and then the client can close the connection. So.
When you're using this pattern, typically how long are you keeping people? How long do they connect? Is that like days sometimes, or like we'll just like I'm asking practical use cases.
Practical use cases, a lot of them are going to be like stock tickers.
Okay.
So you're visiting the site, it keeps connection open.
Okay.
It could also be you can use chat as well, have a chat as well. So for chats, you would have the connection open while the chat's open, but you might close it afterwards or when you close it. So you have to figure out where that sweet spot is.
So SARs for the stock ticker can be open as far as from whenever the stock market opens until the stock market.
More like when you take and connect to the page and to when you leave.
So it could be days.
It could be. But at that point, your server could come back and say, hey, you've been here too long, disconnect and reconnect when you come back.
What I keep thinking in my mind is phone apps, right? Discord's open on my phone right now. Get notifications all the time.
Yeah.
Would this solution make sense? Because this means that my phone has that, something is always running sending messages, right?
Correct.
What's the difference between this and WebSocket?
We'll go into that here. That's my WebSocket is my next item. So
I figured that's what it means.
yeah,
I was saying on that, you probably send different texts, the receiver is open, so are you sending a message, or are you just sending a message that, hey, there's activity, go check it out?
yeah. And most the with React Native, there is a way that the phones will tell React Native that the app is in the background. So you can close the connection while it's in the background. So, okay, moving on to the next part. This is just a quick code example. It really shows you how easily this one is set up compared to the others. You don't have to worry about timeouts. You don't have to worry about interval IDs. Because the browser does a lot of this, the reconnection for you, you don't have to worry about that. So this is why the client-side complexity is very, very low. You can have, I will point out one other thing is there's the on message and on error. Technically, you can send more than just messages across. You can send different event types. So that's something I would say if you want to look into, take that as way as homework. So, next item, WebSockets. WebSockets is kind of like the original, how do I talk with the server in real time? WebSockets is bi-directional, so it's not just the server talking to the client. The client can also talk to the server over the same channel. So from a animated networking sequence, client talks again, server talks back, server talks back again, client can talk. And yes, my homework was by my dog. Okay. Going into the cost and complexity table, cost for this one again is going to be in your mid to high. This has the same issue that server-side event has when it comes to needing that long-running event. UI complexity, there's actually a reason why I put UI complexity as high, even though if you look at probably the code example, you might question why not, why is it? This is going, I'll get into that because it's going to have the same issue as both with the server and security complexity values. So for security, it's going to be moderate to high. And security is going to be high, server is going to be moderate to high. The reason why all of these are that either that high level or moderate to high level is because there are major issues when it comes to how fast data can come in and how it's handled. You can actually take and DDoS your server or even your client relatively quickly. So if your client, I'm trying to remember the correct name for this. Starts with a B. I wish I had my notes. It's on my notes. But basically what happens is your client will get so many messages and it can't process them fast enough, and it will actually take up your entire memory on the client, effectively freezing your client. This can also happen on the server too. So if the client sends a boatload of data and the server can't process it fast enough, it'll eat up memory there. So you have to actually put in mechanisms in order to take and alleviate that, and that could be as simple as saying, the client says, hey server, you sent me too much, pause all the data coming down to me. Another one is sampling. So only take 1 out of every 3 messages, or only take a specific type of message and then throw everything away. So if you're on a chat that has a message of the other users are typing versus a message of here's an actual message from a user, which one's going to be more important? The messages from the user. So if you get into that place where your memory's filling up, throw away all the typing messages. Just use the user message. So as you can see, again, it's very simple. I actually just noticed something here. There's actually a security issue with this code. And that's the fact that it's using WS. It should be actually using WSS, which is WebSocket's version of the HTTPS. So this code can actually have man-in-the-middle attacks. So, and also with the WebSockets, this one, you can also send to different events. You do have to, I'm trying to remember in this one. This one's just parsing the data as it comes in. You can also include streams in this if you want to. I'm not going to go into streams because that's another complex topic that someone else can give a talk to. Hint, hint. So, quick wrap up. So, network communication has a ever-changing topography? No, not the right word. Topology, I believe is the right word. So there's a little bit of homework that I have for you guys. This is just like more of a continuous education. Go out there, take and learn. But there's also 2 new items out there that came out. One of them is the Web Transport API. This currently is not supported by all the browsers. If you actually take a look at the MDN coverage chart, it's actually red, but it's coming out with HTTP 3. So, and the next one is the WebSocket Stream API. This one is actually came out to fix a lot of the issues that WebSockets has when it comes to the security issue I brought up, as well as a couple other things. But again, that one's also not supported by old browsers, but it's something probably to look into.